All right. Well, thank you all for coming. My name is Eric Kuck. I am a principal software engineer on the platform team at Reddit. My team is responsible for just about anything that is not a feature. So we work on performance, developer experience, CI, app architecture, about a million other things. One of those things is our build system, which is what I'm going to be talking about today. We're going to be going through how Reddit's usage of Gradle has advanced in recent history. We'll cover the dark days, as well as our current state, and how we got to the point of where we felt worthy of doing a droidcon talk about it. Before we do that, let's do a super quick refresher on some Gradle basics, just because we will be going over these things, and not everyone's super familiar. It will be fast, don't worry. So first of all, a Gradle build has 3 build phases. There's initialization, configuration, and execution. So the initialization phase is responsible for executing your settings.gradle script. It will create settings instances, and it will create project instances for every project that you have referenced, for every module you've referenced. Then it moves on to configuration once that's done. This is what actually executes the build script of every project. The entire script every time. So if you have a bunch of stuff that doesn't belong in there, you're going to be wasting a lot of work. It creates a DAG of task objects and then moves on to execution. This is where it schedules and executes all the tasks that were requested when you started the build. And dependencies between tasks will determine their order. Talk a little bit about caching. There are lots of different layers of caching. So there's the in-memory cache. That is basically the Gradle daemon. In project, those are going to be your build folders. Your dependency cache, that's at your home directory, the .gradle file, or folder, I guess. It has all your dependencies that are shared between all your builds. Then you have a local task cache. That is what is going to be caching the inputs and outputs of any task that you've run. And then there's also the remote task if your company has that enabled. It's basically the same thing as the local task cache, except remote, as the name implies, so that everyone can share. Basically, if CI has already completed a task, why do you have to do it again locally? So now we're going to get into an anatomy of the task. So there's 3 parts. There's inputs, actions, and outputs. Your inputs, so this isn't completely true. This is how we try to think about it. Anything compatible with a configuration cache can be an input. You can actually do a lot more than that, but you probably shouldn't. These are set by providers and properties. And if a task's inputs are unchanged and it's in the cache, it will not be re-executed. Up next, we have our actions. These are what run when inputs have changed or if a cache state is not available. Tasks can have lots of actions, and this is where all your expensive work is going to go. Finally, we have outputs. Again, anything compatible with a configuration cache doesn't actually have to be true, but it probably should be. And these will get reused on cache hits. All right, now really quick, we're going to talk about alternative build systems. This comes up almost any time Gradle is brought up in the Android world. A lot of larger companies have moved to build systems, mostly Bazel or Buck. There are a lot of advantages to these systems. They are often faster, at least in public perception. They can offer more aggressive caching. Remote build workers for distributed execution, particularly with Bazel. They do a pretty good job with that. Some of these have no configuration phase whatsoever. You get to skip that whole painful step. And some of them offer more familiar build script languages. So for example, Bazel uses Starlark, which is basically Python, which can feel a lot more natural than Groovy. And yeah, sure, we can use Kotlin now, but honestly, it's still a little awkward to use a type-safe language in a build system that was kind of designed around being dynamic. So with all those things said, why are we using Gradle? Sounds like there's a lot of advantages to not doing it. Actually, there's a lot of reasons. We have experimented with lots of things, and we keep coming back to Gradle just being the best option for us. There's a few reasons. So for example, you get new things first. We were very, very early adopters of Compose. We actually started using it before, I think we started when it was still in alpha, actually. We didn't ship anything, but we were doing stuff with it. So this would have been much more difficult if we were using Bazel. The other thing is just it has full support from Google. When new things come out, they're going to support it, and then there are existing things that have been out for a long time that Bazel still doesn't do very well. For example, dynamic feature modules. Honestly, there's still a lot of sharp edges and bugs with Bazel Android. If you just search for team-Android on the Bazel repo, you're going to find a lot. And the last thing, just kind of being honest, we don't have a dedicated build team at Reddit. Maybe if we did, things would be different. Maybe we would have the ability to spend enough time to do some of these things ourselves. But we don't. We have a platform team that does a lot of things, one of which is builds. So having these things provided for us out of the box is super handy. All right, so this is kind of what the meat of the talk was about. Oh no, sorry, it is not. First, we're going to talk about the Android Gradle plugin. I found out they don't have a logo, so I just kind of found one on the internet. If anyone from the AGP team is here, you should probably get a logo. All right, so AGP is designed to extend Gradle to add support for Android. It does a lot of things, resource processing, build variants, build config, minification, obfuscation, dexing, signing. Note that it isn't necessarily doing all these things directly. For example, minification and obfuscation is actually done by R8, but AGP acts as the Gradle bridge that allows you to use this in your project. Typically, you would interact with AGP through DSLs. These are the million things that go into the Android block of your build script. And it is actually highly extensible. They have done a very good job making sure that people can build on top of it. It exposes some really nice lifecycle events, and it has APIs for almost everything. And without those, we would not be able to get into what we're doing on the next slide, which is the Reddit, can't say my own company's name, the Reddit Gradle plugin. So this is what we have come up with that allows our builds to just be so much better than they were in the old days. But first, we are going to talk about those old days and what led us down this road in the first place. So when I joined the company a little over 4 years ago, builds were slow, the setup was very confusing. Our CI actually times out after 2.5 hours. Ask me how I know that. I should not know that, but I do. Yeah. Among the various problems we had were things like we had a lot of ad hoc plugins. Since we didn't have people doing a dedicated centralized tool, people would encounter some build issue, and they would take it into their own hands to find a solution. And often, that would mean that multiple people could solve the same problem in different ways, and we would end up with plugins on the class path that don't necessarily go together. We also ended up with non-build Gradle files absolutely everywhere that did lots of different things, sometimes the same things. We had several right ways to do things, which just always leads to confusion. Every single build script was its own special flower. And this actually causes more issues than you would think. One person doing a slightly wrong thing, and for example, breaking the configuration cache, actually breaks the configuration cache for everyone. So allowing anything to go on in your build scripts is actually quite dangerous. Another thing we had a lot of was copy and pasted build files, which led us to have a lot of unnecessary dependencies and plugins. People didn't necessarily know what something did, so just to be safe, throw it in there, right? And as I alluded to earlier, configuration caching was absolutely broken, and we just had to have it off. Continuing my complaint list, we had modules, all the modules configured, even if they weren't going to be used. Eager evaluations were absolutely everywhere. For those that don't know, eager evaluation is when you evaluate a property before it's needed. Typically, this happens at configuration time. It's entirely possible that this property isn't actually needed at all, and it's just entirely wasted work. So generally, good thing to avoid. We had decentralized, often conflicting dependency management, and we had a lot of imperative build logic kind of scattered around. This build logic, since we use Groovy, was interpreted dynamically at runtime, which was very slow and a waste of RAM. And did I mention that the standard Reddit MacBook at the time had 16 gigs of RAM, so this was extra painful. All right, So I complained a lot, but how did we end up there? Honestly, it's the same way a lot of companies do. Developers just want to build cool features, right? I mean, who cares about the build system? Very few of us got into mobile development to work on tooling. We want to build cool things that users love. Gradle is super flexible, so it is very easy to get something working the way you want and just kind of move on, not actually paying attention to if you did it the right way, or if it's performant, or if it's reproducible, or if it's going to break something for anyone else. And also, I mean, kind of like anything else, there's a lot of really, really terrible advice on Stack Overflow that is very easy to copy-paste. So we had kind of an aha moment. We had been talking about these problems a lot. We had experimented with possible solutions, and we hadn't really found anything we liked. And then I came across this blog on the Square Eng blog by Tony Robilic. If you haven't already read it, I would very highly recommend it. Square set out a set of basically 4 goals that they had when they were looking to advance their build tooling. First was to enhance maintainability, then to make it easier to upgrade to newer versions of Gradle or AGP or KGP, to eliminate cross-project configuration so that every module could be configured independently from the others, and to regularize the build scripts so that they could be parsed outside of the Gradle ecosystem. These are all goals that we've been talking about for quite a while. So for us, just kind of seeing it on paper, seeing how it was approached by Square was super helpful. Again, we don't have a build team, so seeing success in others was great for us. So now let's talk about where we are today. No, I'm just kidding. Everything's great. Here is an example build script that I actually copy and pasted out of our code base. This is a real one from one of our more complicated modules. It's not cherry-picked because it kind of sort of fit onto a slide if you use small font. It's pretty representative of the average complicated module in our project. So every module has the same layout with 3 and only 3 blocks. First, we have the plugins block, which will apply one of the convention plugins that we have designed. This one uses the Android library convention plugin. We also have one for Android apps, JVM libraries, Android test projects, lint projects, I don't know, quite a few, that will configure your builds in a very helpful way and take a lot of the busy work away from you as the developer. Next, we have the Reddit block. This is where a lot of the interesting configuration is done. We have a lot of features that come out of the box. We'll go through a bunch of these later on, but you can see the general shape of most of the options here. Everything's configured via methods that optionally take lambdas that will allow you to further configure the feature. So here you can see we use GraphQL we use Apollo for our GraphQL code generation. This is setting up consumers and services. We use Jetpack Compose. Not only the Jetpack Compose runtime, but also UI, along with our design system. We use Dagger. This particular module configures all that with Anvil and has it set to generate the Dagger properties. And it uses Moshi along with CodeGen. And the final block is dependencies. Really nothing interesting here. It's the same as you've seen everywhere else, so I won't talk about it too much. So what does all this give us? The first one is cleaner build scripts. Anyone on the team can glance at any build file and know exactly what it's doing. There's really no surprises anywhere. Having consistent formatting like this means we can build tools outside of the Gradle ecosystem. It can be Python, Kotlin, whatever it is. And we can do cool things with it much faster than you could actually do in Gradle. So for example, we have a script that configures projects, which projects are included in our settings.gradle file, basically focus on the thing you want. We have several apps, sample apps, as well as the main app. And if I'm a developer, I might only want to focus on my sample app, so things like IDE syncs and configuration times go significantly down. We also have a task that rewrites build scripts and optimizes them and sorts their dependencies. And additionally, since build scripts never do anything unexpected, we haven't had an issue with the configuration cache in absolutely forever. Developers would actually have to go pretty far out of their way to break it at this point. And And finally, it just allows us to apply fixes for build issues globally. So here's kind of a system diagram of the first stage of what we call RGP. So RGP, Reddit Gradle plugin, is really several plugins in a trench coat. First, we start with what's here, the settings plugin, which, as the name is implied, is applied to the settings.gradle file. So settings.gradle file gets the settings plugin. So at the top of the talk, we went over what happens during Gradle's initialization phase and how the settings.gradle script is read in and the settings instance is created. This is really the earliest point that we could hook in to get things configured in a convenient and reproducible way. This is where we do a lot of configuration. We also set up build services that can be queried by all of our project plugins later on. Example settings we have here are compile and SDK targets, various things for test coverage. It allows us to do a lot of mass migrations, like moving over from CAP to KSP with Room, or enabling KSP in Anvil. It also allows us to do things like dependency resolution overrides. And the settings.gradle file is also where we would put things on the class path to inform RGP how it should function. So for example, if we have Kotlin 1.8 on the class path, it's going to do things a little bit different than if Kotlin 2.0 is on the class path. It's smart enough to kind of know what needs to be configured in which situation. And the same for AGP upgrades. All right, because we have a settings plugin and it happens so early, we're able to do some pretty neat tricks. So for example, if we're executing a task that we know doesn't actually need any of our project modules to exist, we can do some pretty cool optimization. So what I called the configuration bypass here will simply make Gradle believe that there are no project modules, that all we have is a settings.gradle. And this is really cool because it allows us to bypass a ton of initialization and configuration time. It's used for our bootstrap task, which we will demonstrate here. So here I'm running it, and it's done. Also, I just really like showing off my ASCII artwork. So configuration on our project takes somewhere around 2 minutes, but as you can see, that took a little bit under a second. And that's because we basically tricked Gradle into thinking we didn't have any projects. Bootstrapping has done a lot for us. So like I said, we used to have 16 gig MacBooks, and everyone was generously upgraded to 64 gig MacBooks. But a few weeks later, we were going through our build analytics, and we noticed that build times weren't really improving for a lot of developers, and we weren't sure why. And it turns out that a lot of them left their JVM args the same as it was on their old laptop, and they were still building as if they had 16 gigs of RAM, seeing absolutely no benefits from their shiny M1s. So this bootstrap task exists to kind of analyze their hardware and figure out what the best JVM args would be for them. We use it locally, we use it on CI. It's kind of used everywhere in every situation to just optimize the build for us. It also does things like set up our Git hooks to make sure that everyone is all onboarded with all of our checks. All right, and here is potentially the more interesting part. This is what we had looked at earlier. So this is kind of another system diagram of the project level plugins for RGB. So we're going to start in a project module. This is just your build.gradle file that exists in absolutely any module. They are going to call into a convention plugin, like I mentioned earlier. Here's the list of several of them that we offer. And then those convention plugins are going to do a lot of work. They're going to apply the platform plugins, Android app, Android library, dynamic feature module, JVM library, whatever it might be. It's going to apply some common plugins that we want every project to have. So for example, module visibility. We have a pretty rigid module structure to avoid things like circular dependencies, which used to be huge issues for us. And this will make sure that you have modularized your feature correctly and that you're not accessing any features that you're not supposed to based on the rules that we have set up for that. Also does detect. It sets up a lot of common dependencies, such as the lint rules that we use internally. And it just does a bunch of other setup, language configuration for Kotlin and Java, dependency resolution stuff, module type validation, so on and so forth. And probably the most interesting part is what we call our feature registry. So the feature registry manages configuration units that we call project features. These do a huge range of things. And we have built-in facilities to register features that can manage other plugins, dependencies, or even configurations. They can either do some basic setup with these, or they can declare themselves as the sole manager of the plugins, dependencies, and configurations. So for example, we have a project feature that manages Dagger and Anvil. This will make sure that you are using the way we have set up so that you're doing it correctly. And if anyone tries to apply the Anvil plugin or does anything with its configuration or adds a Dagger dependency manually, this will actually error out their build to make sure that we don't get back into this world where every build script is a special flower and everyone is doing something differently. We also have an affected module service. This basically just spits out a huge list of tasks that we can do only if the module that it references was affected by your Git diff. It does a lot of cool things like calculating test shards for us. So when we put up a PR, if it affects 300 modules, we probably don't want to run them all in the same CI worker, so we shard that all out. This uses the little initialization and configuration skipping hack that I mentioned earlier so that it can spit out the Git diff and the test shards for us very, very quickly. It will also create tasks for affected tests, lint. We can even compile just affected modules. Other features that we have, Compose, we saw that earlier. You can set up with UI, with our design system. You can even set up just the runtime. Incidentally, our view models are also powered by Compose, so it is often handy to be able to bring in Compose without bringing in all the UI bits. We can set up Dagger, Anvil, like we talked about. We can enforce dependency rules. We have a bunch of stuff around telemetry. We use Gradle Enterprise, or I guess Devlocity now. And this will set up all the keys and tags correctly with them. And we also do some custom endpoints for build analytics. This helps us to do things like dashboarding and looking at trends a little more easily. What else do we do? We do some secret management. So we keep all of our secrets in 1Password. And what we used to do was copy them all out of 1Password into a plain text file that accidentally got leaked all the time. So to get around that, we now are just able to communicate directly with 1Password using the CLI and make sure that our secrets stay at least relatively secret. We automatically configure lint, KT-lint, detect all these things with our custom rule sets. We disable debug build types for library modules. This gives us better cacheability and decreases configuration time. The way we did this is pretty cool, and it would have been pretty difficult to do this in such a convenient way without something like RGP. So what we do is if a module says that it needs a build config file, they don't have them by default, but if it says it needs it, we hard code debug to true. Because if you're a developer, you probably are relying on that for checks to see if you're in a debug build. So it's always true. And then our plugin will apply a special RA configuration that sets the field to false only for release builds. This is something that we could wire manually, but would be really, really difficult without a plugin like this. Again, it just does a ton of other stuff. Deep links, GraphQL code gen, lint baselining, Moshi, permission allow lists, room, dependency optimization and sorting, custom coverage with IntelliJ's coverage agent, and yeah, the list goes on. Yeah, I guess that is the bulk of the talk. If anyone here is struggling with their builds and doesn't already have anything like this set up, I would highly encourage you to explore the option. There's a lot to gain here. We have cleaned up build files a ton. I really should have taken a screenshot of the GitHub diff of before and after. We took out many, many, many thousands of lines. Much lower cognitive load for all of the developers. We've improved build times. We've improved configuration times. Assuming that you have some sort of not great stuff happening in any of your build files, this could be helpful for you too. It guarantees configuration caching could work. You can be prepared for project isolation. It sets you up really well for mass migrations. You can apply fixes for build issues globally. It allows you to centralize logic and leaves you better positioned for future opportunities. And it allows you to create lots of built-in tasks that anyone can use or CI can use. Just a few helpful links if you are looking to get started with something like this. The first is the blog post I mentioned earlier, Herding Elephants by Tony Robilik. And the second, so Slack has a pretty similar Gradle plugin. Theirs is open source, ours is unfortunately not. They do a few things we don't do, we do a few things they don't do, but it's a pretty good resource. If you are looking for some concrete examples, I would highly encourage you to check that out.